Have you ever wondered where stars come from? Or what those stunning, colorful clouds in space are? Welcome to our cosmic exploration, where we delve into the mysteries of nebulae, the celestial nurseries where stars are born. These astronomical phenomena are more than just beautiful, they're full of secrets waiting to be discovered. Prepare yourself to unravel the intricate processes that give rise to these awe-inspiring cosmic clouds. Stay tuned as we embark on this cosmic journey to understand the formation and evolution of nebulae. It all begins with a star, much like our own sun, reaching the end of its life. Now imagine this. A star has been burning bright for billions of years, its core fusing hydrogen into helium, producing a tremendous amount of energy in the process. But, like all things, it can't keep this up forever. As the star exhausts its hydrogen fuel, its core starts to shrink under the immense pressure of its outer layers. This triggers a new phase in the star's life, the red giant phase. In this phase, the star expands dramatically, its outer layers puffing up to hundreds or even thousands of times its original size, while its core continues to collapse. The star's core becomes so dense and hot that it begins to fuse helium into heavier elements like carbon and oxygen. But this can only go on for so long. Eventually, the star's core can't sustain the pressure anymore. It collapses in a fraction of a second, triggering a cataclysmic explosion known as a supernova. This explosion is so powerful that it can outshine an entire galaxy, albeit briefly. In the wake of this explosion, the star hurls out a vast cloud of gas and dust into space. This cloud, rich with the remnants of the star's life and death, is what we call a nebula. Among these remnants are the heavy elements produced in the star's core, the building blocks for new stars, planets, and potentially life. But the nebula isn't just a graveyard for dead stars. It's a birthplace for new ones. Over time, the gas and dust in the nebula start to clump together under the force of gravity. These clumps grow denser and hotter until eventually a new star ignites, marking the beginning of a new stellar life cycle. So, in essence, nebulae are stellar nurseries, born from the remnants of their predecessors. Once a nebula forms, it doesn't stay static. It evolves, it changes, and it gives birth to new stars. Imagine a nebula as a celestial nursery, a place where stars are born. This process begins with the nebula's abundant supply of gas and dust. Over time, due to the invisible pull of gravity, these particles start to clump together, a little like how you might see dust particles gather in a sunbeam. As these clumps grow larger and denser, they create a gravitational pull of their own, attracting even more gas and dust. This process continues, with the clump growing larger and denser until it forms a protostar, the embryonic stage of a star. Now, a protostar isn't a star just yet. It's more like a star in waiting. It's hot, it's dense, but it's not quite hot or dense enough to trigger nuclear fusion, the process that makes a star, well, a star. But give it time, the protostar continues to grow, feeding off the gas and dust in the nebula. And as it grows, it gets hotter and denser. Eventually, the pressure and temperature at its core reach a critical point, igniting nuclear fusion. At this point, the protostar turns on, becoming a full-fledged star. It begins to shine, radiating energy out into the cosmos. This is not the end of the nebula though, not by a long shot. While one star may have been born, countless others are still in the making. And even after all its stars are born, the nebula continues to evolve. The intense radiation from the newborn stars can blow away the remaining gas and dust, causing the nebula to fade away. But even then, the materials blown away can come together elsewhere in the universe, forming new nebulae and starting the process all over again. In a way, a nebula's life is a continuous cycle of death and rebirth, creating the brilliant stars we see in the night sky. Not all nebulae are alike. In fact, there are several different types, each with its own unique characteristics. Let's begin by exploring emission nebulae, the divas of the nebula world. They're literally the star of the show. These nebulae are predominantly composed of ionized gas that emits light of various colors. They're like the universe's own neon signs, glowing brightly as they're energized by nearby hot stars. The iconic Orion Nebula is a prime example of an emission nebula. Next, we have reflection nebulae, the mirror images of the cosmos. They don't produce their own light, but they reflect the light of nearby stars. Imagine them as cosmic clouds scattering starlight in all directions to create a soft, ethereal glow. The Witch Head Nebula, with its eerie blue hue, is a beautiful example of a reflection nebula. Then there are the dark nebulae, the enigmatic shadow figures of our cosmic stage. They're dense dust clouds that obscure the light from objects behind them. They're like the universe's own game of hide and seek, hiding stars and other celestial bodies behind their dark curtains. The Horsehead Nebula, aptly named for its distinct shape, is a well-known dark nebula. Finally, we come to planetary nebulae, the swan songs of medium-sized stars like our own sun. They're formed when aging stars shed their outer layers, creating a shell of ionized gas that shines brilliantly for a few tens of thousands of years. The Ring Nebula, with its vibrant ring of glowing gas, is a classic example of a planetary nebula. Each of these nebulae forms under unique circumstances, and each has a distinct appearance and life cycle. Some glow brilliantly, while others hide in shadow. Some reflect the light of others, while some are the final, beautiful goodbye of a dying star. So while nebulae may all share a common origin, their life stories can be vastly different. Nebulae are more than just star factories. They are cosmic wonders, full of mystery and beauty. Let's dive into some of the fascinating aspects of these spectacular celestial structures. The first thing that strikes us about nebulae is their sheer size. These colossal clouds stretch across light years of space, dwarfing our entire solar system. To give you a sense of scale, if our solar system were the size of a coin, a nebula could be as large as the Earth. But nebulae are not just about size. They play a fundamental role in the cosmos. These cosmic nurseries are where stars are born and die, recycling their material back into the universe. This stellar cycle of death and rebirth ensures the continuity of cosmic evolution, making nebulae the beating hearts of galaxies. Speaking of hearts, have you ever wondered why images of nebulae are so breathtakingly beautiful? The credit goes to the different elements within them. When a nebula's gas clouds are heated by nearby stars, they glow, producing stunning colors. Hydrogen gives off a red hue, oxygen emits green light, and sulfur radiates in red. The interplay of these colors across the vast canvas of a nebula creates those mesmerizing images we all love. These images are not just for show though. They provide invaluable insights to astronomers about the nebula's composition, temperature, and density. With each new image, we unravel a bit more of the cosmic mystery that nebulae represent. Yet, despite all we know, nebulae continue to be enigmatic. Their vastness, complexity, and sheer beauty make them subjects of ongoing study and sources of endless fascination. Each nebula is unique, with its own story to tell, a testament to the diversity and grandeur of our universe. Indeed, nebulae are the colorful canvases of the cosmos, painted by the very stars they birth. The next time you look up at the night sky, remember that you're gazing at the work of masterful cosmic artists, crafting breathtaking spectacles across the vast expanse of space. We've journeyed through the life of a nebula, from its birth to its role in star formation and its many forms. As we've seen, nebulae are not just random smudges of light on the cosmic canvas, but complex and dynamic entities. They are born from the remnants of dying stars, and over millions of years, evolve into stellar nurseries. This transformation is a testament to the cyclical nature of the universe, a cycle of life, death, and rebirth that plays out on a cosmic scale. We've also explored the different types of nebulae, from the glowing clouds of emission nebulae to the dark, mysterious regions of absorption nebulae to the beautiful shells of planetary nebulae and the remnants of supernovae. Each type is unique, and each tells a different part of the story of our universe. And let's not forget the wonders of these celestial clouds. The intricate shapes and vibrant colors we see are not just aesthetically pleasing, but they also provide valuable insights into the physical and chemical processes happening within these cosmic nurseries. So we come to the end of our cosmic journey. But remember, every end is a new beginning. The death of a star gives birth to a nebula, and the nebula, in turn, births new stars. So, next time you look up at the night sky, remember the cosmic nurseries that birthed the stars and marvel at the wonders of our universe.